Hello, hello. It's been a little bit, but we are back. So, for anyone watching the VODs, there's an update since the last one. So, we are back to building, but we are not yet. We're almost where we want to be in terms of functionality. So, if we print the tree here, as you can see, function call. The first child of a function call used to be the expression. And then from there it was the parameters that you passed. Now, children start right at the first parameter, and the expression for the call is here. It's in the struct as a parser node, which we can print out here. So in this case, this is the call to write, which is here. So other thing is declrefs also they still have the decal name here because I haven't removed it fully yet. But for the most part, they now have this decal identifier, which is basically what is letting it concatenate multiple things into one identifier. So for example, whatever you pass in here as arg, this would be std concatenated with whatever you sent it, underscore file number. This identifier here is a linked list. So this expression here is a linked list of either a string or a node. In this case, it's a string, std, a node, which is this concat directive pointing back to arg, and then another string, underscore file number. And on the tree, we can construct that here so we can see this is what this is. I can probably change this to, instead of just show that, probably show the whole directive, but it's not that important right now. In fact, let me put a to-do there just so I can remember. Construct node name is what we're at. Yes, so where do we actually do that? We're doing that here somewhere. Huh. Well, I'll just put a do here. Okay. Anyway, so next thing we have to do is if I try to compile this, what's happening is wait. Oh, because this needs recompiled. Okay. Have to recompile the metaprogram. So, you know, that's another to do. Whatever, it's fine. So, when we spit out the code does not yet know about replacing these snippet calls with what's in the body of the snippet. That's what's happening right now. So, here we go, update function call if snippet. Now we're grabbing the expression. I kind of stopped halfway through there, or through here, so is this assertion still the correct thing? The rest of this function seems to assume that it's a decal ref. So here we're making sure that the expression is either a decal ref or a preproc expression. Which I think it's always going to be a decal ref. This thing. So what if, for example, we don't do anything except concat this? Yeah, this is always going to be a decal ref. And this decal ref will be a concat node. So that's fine. We can just assert that. Okay. Put this back. So now we construct the node name. Let's just print out the node name. Make sure we're getting what we think we should be getting. Right. We aren't using the decal ref here anymore, so let's just comment these out. Let's just not do anything else except print out the name for now. There we go. So we got write and we got testing. So here's a function call. Oh, right. Really what we want to do, that's just printing out all the function calls that we're trying to update. Here we're looping over all the snippets and seeing if they match. So let's only print it out if we know we found one that matches a snippet. There. So there's only one function call in our whole program. It's right here. That matches a snippet. It's matching this one. So in that case, what do we do here? The expression could still be just a decal ref with a decal node, no problem. However, what if it's a constructed identifier that ends up being one? Does that make sense? Does this get handled in the multipass nature of the code gen? Okay. The expression could still just be a decal ref with a decal node. So here's where we're checking to see if this decal ref connects to something. Multipass nature. This doesn't actually, okay. I think I'm confused about what this is actually doing. So we're saying if not decal ref, let's grab the decal ref then. We do actually already have it. So we don't even need this anymore, right? If we don't have one, return false, then we just assert that we have a decal ref. So, we get the name, and we'll grab decal ref, which is just the expression. We'll call it decal ref from now on. And if not, we'll just grab this, right? If the decal ref is not connected to something, so in our initial step where if we failed to connect this to a function call in the post pass, it means this must be a snippet. So now we should see in this tree that be a snippet call. Oh, Okay, could not resolve. Okay, hold on. Oh, because we're not doing this. Okay. Right. Okay, let's just keep going then, because this isn't going to work until we get through here. So this, I don't think actually matters. That doesn't make any sense. No longer do the -1 snippet, right? So, okay, let's just uncomment this now and just start making this work. So, num valid children, we no longer have to -1 this, because the expression is now stored separately. It's not on the tree. So, we'll call this num call params and num snippet params. So we're going to count the snippet params. Yeah. Link this up. Does that now mean override the expression? Or actually, I think we linked up the expression to go on expression. Yes. So, if the number of call params is greater than or equal to, why greater than? Because this logic is not quite right. If the last parameter is an ellipses parameter, in fact, why am I checking the name? Don't we have... Maybe we don't. Okay, maybe we don't. Okay, maybe we don't. That's fine. In the case where the node, or the declref, in the case where the snippet takes an ellipses parameter, then we can match to it if we have more than what it has. But only in that case. So, let's do this. Ellipsed is false. We're going to say, do that, and then if it's an ellipses param, actually, let's do it this way. We'll keep doing what we're doing. If it's not an ellipses param, we can add +1. Otherwise, we'll make it ellipsed. Okay. So, if it equals num param, or num snippet params, or ellipsed, and it's greater, right? Right? So if it's either the same, or if it's, let's flip this around for logic's sake. So either they're the same, right? Or they're greater, but it's ellipsed. Then we found a match. So declref, we can link it up. Okay, that's not good. We're still failing that. Why? Can't resolve snippet source for call. We don't have a call there. That's fun. Resolve snippet source. Replace snippet calls. Oh, so this logic I think is going to have to change. So let's not do this for now. Okay, so now this function call down here, great. It's a snippet call. That's great. Right, snippet call and function call are the same thing here. So construct node name function call. This should also be for snippet calls. There we go. Great. So now we have a snippet call. So really, you're never going to see this on the tree ever, because if there's ever a snippet call, it's getting replaced with the body of the snippet. But that's what I just turned off. That's this, right? So you are never going to see a snippet call on the tree, because whenever you would, this post pass here, this replace snippet calls, is going to grab this, or it's going to find which snippet this corresponds to, which in this case is this one, and it's going to take the whole body here and insert it into the tree here. That's what this function's for. So if we put this back in, couldn't resolve. Okay, so now we have to figure out why this is not working. Resolve snippet source. Okay. So we're going to loop through the program until we find, and we're going to keep doing it until we're out of snippet calls, because sometimes you can have a snippet call inside of a snippet. Like, I can't go back because I cleared it. This snippet here could call a snippet inside of it. It could call another snippet. So when we replace this, first we replace it with this thing's whole body, which might have a snippet call in it. So we have to go again to see if we have to replace any more. So we'll do it until we're done. Anytime we find a snippet call anywhere, we're going to keep going. So that's fine. Let me double check something here. I should probably sit up. Okay. So now, for each snippet call, if we're in a snippet, oh right, because we don't want to replace them in the actual snippet itself, right? We don't want to replace it in the code that's in the snippet. We want to only replace it in places where we called it. So that's fine. Aha. Okay, so this declref node is no longer the first child. This is the node's expression. And we're going to assert. At this point, if it's a snippet call, we know that the first thing is the declref, because that's what that... We actually know it is, but I'll still put this here. That thing we just did where we replaced function calls with snippet calls, we already verified. This, so, but that's fine. So if we're at the point where we're seeing snippet calls, we know that they're good, but that's fine. So, that's fine. We can remove that. So if not declref, boom. So that's why this was failing, is because we weren't looking at the right thing. Now we are. So why, though, did we not have... Oh, and that's why we didn't have this either. The name we didn't have. We didn't actually hit this. We hit this one. So snippet source is we get the node that it's pointing to. If we don't have it, which we should, if we linked up this to this, we should have one, then we print out this error. Let me go back real quick to function call if snippet. Was there something I forgot to do in here with... No. Okay. we are now going to the numparams call, the numparams on the call, and the numparams on the snippet. All right, why are we minus oneing? The call makes sense. We just grab all the children. The source, though, why are we minus oneing that? Why are we minus oneing that? Because this source should be this. I think all of these need to be anywhere we could have a name. I think needs to be an identifier. Okay, why? Here, let's turn this off again. 1943. Right, this needs, oops, this is an info expression decal ref, no, expression function call dot expression. Where's function call in here? Do I have? Expression. This is a function call and a snippet call. Okay. So, snippet. Its first child. Oh, because it has a body, right? That's why. We're not counting the body. It's child, child, child for parameter, parameter, parameter. The very last child is the body. And we're not counting that as a parameter, obviously. So that's fine. The new snippet source is nothing yet. If the snippet has parameters, that's the only time we have to replace stuff. We create a copy. We concatenate things. We update the decal refs. Copy the new body. A simple copy of its body's contents. Insert the snippet in the tree. Do we have to do it? Are we just good here? I'm gonna guess not, but yo, we are. That just worked. That just worked. If I go to the output now, that totally worked. That old code is still working. So, well, not entirely. We're not out of the woods yet, but you can see testing. I passed it out. It should have replaced that snippet call with a function call to write with 3 parameters. Function call to write, 1, 2, 3 parameters. And the only thing it didn't do is replace this arg, the concatenation. It didn't replace that yet. Why? Let's see why. Do concatenation on snippet copy node. Do concatenation. Relying on above assumption. Oh. This was back when I had @ symbols for concatenation. We are no longer doing that. This is an old function. Right. This is no longer how we do things here. That's fine. Okay, so let's just see what we're working with here. So let's just take all this out. Dot name, that's not a thing anymore. We're gonna do for all types in the tree that are variables, parameters, struct members, unit members, enums, blah, blah, blah. For any of those, we are going to print construct node name node arg. That's the only thing we see is, wait. All right, what are we doing here? Let's do this first. Let's print out the copy. So we made a copy of testing. We want to loop through anything. Do we have concatenation nodes? How did I forget how I did this? Let's go to the parser and look for concat. Token concat. Append identifier node. Parse expression. Where are we doing? It's not a preproc, it's a concat node. See, I don't remember how we are parse identifier. append identifier node. Here we go. So if it's an identifier, we just grab the text. It has no node. If it's a concat, we expect an open paren after it, and its node is whatever's inside of it. So I'm not actually saying that this thing is a concat node, which is not great. I think here in the parser, identifier node, right, because if it's an expression, I'm just replacing the whole thing. At this point, if I just see a node like that, I am losing the fact that this was a concatenation node. I have thrown that info away. Here. I'm just keeping what's inside. So I think what has to happen is the node flags. The node flags. I need to add another one of these. Concat. This flag, this node in an identifier linked list is a concat node. So here, flags or equals node flag concat. Okay. These are node flags. Okay. Which means now in CodeGen, I need to look for anything here that has an identifier, which is a variable, a function, a struct, a union. Okay, so anything that has an identifier. So that would be all of these. And how do I, what did we have this as? Query, node query types input. It's a number and an array of types. So we have all these. We have I missed these. We have these, I guess. These. Oh, that's gonna have it too. These. Type def has it. That doesn't. These don't. They have an expression. We'll make a special case for these. Okay. Decal ref. Keyword cast preproc param preproc define. So AST expression keyword AST expression cast AST preproc param and preproc define. Is that it? Nope. Snippet and expression. AST snippet. AST preproc expression. Okay. I think that's it. So, the types are, how many do we have here? 13 to 46. So that's 33 minus 2 lines here. 31? Does that sound reasonable? And then we will 1, 2, 3, boom, boom. Nope, that didn't work. We are going to why? Boom, 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 boom. I don't know why that's not working, so we are just going to do this. There. Okay. And then okay. Add one there. Add one there. Okay. So let's just make sure that compiles. Too many initializers for type 16. Is that a hard limit that I have? It is? Alright. Well. Okay. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. 1, 2, 3, 4, 5, 6, 7. Why is there only 27? I miscounted or something. 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7. Okay. Because we're from 40 down to... Oh, I'm looking at the... I was looking at the wrong number. Whatever. Stupid. I was looking at the column, not the row. Okay. So. That's fine. So now let's look at the snippet copy. Anytime we see a concat node, we need to replace its text with the text of the corresponding parameter that was passed in. Let's remove that because that's what we're doing right now. So the subnode is, and let's not call this subnode, let's call this potential like target. We'll say potential target. Target name is that. And we're just getting it as a pointer. I don't know what the above assumption is. Yeah, we don't have to do any of this stuff anymore. Matching function decal param ID. Okay. So, the problem is all this stuff is trying to match the name. We have the name. The name is, I think it's just that. It's just name, right? Because before we were just trying to find a string and replace it. End if. Why is there an end if here? Okay, we didn't see anything. Right? Because I'm not printing it out. It would help to print it out. Target name. So we should be seeing all things that could have an identifier that are inside of this snippet. So arg does, write does, and this expression does. This expression does, this does, and this sub-expression arg does. No, never mind. This is an expression that has an identifier. This has an identifier. This has an identifier. This parameter does. So it's a parameter, a function call, and a decal ref. So now we're going to see only we're only going to look at if not, or if potential target, we're going to say if not potential target, node flags, and so if it's not a concat node, we don't want to print it. So now we should only see that std arg1, and we don't. Why? Because it should be a decal ref. Oh, no, never mind. Okay, this is getting a little tricky. because two things happen here. We concatenate, and then we update the decal refs. So first, we do any concatenating here. So the first thing that happens is we replace this concat arg with whatever you passed us. Then we update any decal refs that need updated at that point. We do the concatenation first. Which let's see. Okay, let's remove this part and just see where we're at right now. So we're seeing everything that I might have to concatenate. So, okay. Here's what we're going to do. We're going to say we know this thing has an identifier. So, identifier is and we're not going to call this potential target. This is just going to be target. Target we're going to say target type is either of these. Right? If it's either of these, we are going to grab the target info expression function call dot expression. Otherwise, we're going to grab the target. Oh, wait. I can't just grab the identifier out. Because these are all different things. They're all going to be in different places. Do I have a function for this? I don't, do I? Construct. Okay, I'm doing that here. Okay. You know what? This is actually probably a better way to do this. We'll do this. Let's grab this whole thing. We're just gonna have a function called get node identifier, and we're gonna pass it a node. Okay. This is result. You know what? Not even do that. We're just gonna do this. Return this. Return this. Return this. Return that. Actually, no, we're going to do this. Get node identifier of its expression. And by default, we will return 0. Okay. So here we can just say identifier is get node identifier of target. And then we just assert that we got one. Yep, this is return. Cannot convert, right, because this is an identifier. Great, okay, we're still good. So, we got an identifier. So let's construct, or let's, while identifier equals identifier next, we're going to say if identifier node wait a minute, did I right. If this identifier node has a node and its node flags, node flags tells us it's a concat node, then I want to print target name. Okay, now we should only be seeing this, because this is the only one that has a concat node in it. But we're not seeing anything. So while identifier. So do we get an identifier back? We have to, because we're not asserting. So if it has a node and its node, what if we just do this? Okay. So that makes sense. Why are we not getting, we're not setting that flag properly? We should be, though. Are we not copying it? Snippet copy. Create node copy. No, we're setting the flags. Oh, we're not copying the identifier list. Shit. When we create a copy of a node, we are not copying the identifier list. Crap. That's a problem. So the whole node is getting its node flags, but we're setting this concat node on one of these inside the identifier node. So we need to have a copy identifier between nodes. Copy identifier node, copy identifier list from a source to a destination, and identifier node oh no. And once again, I'm going to have to dispatch this to get to the identifier node. Well, actually, I don't know if I have to do that. If I pass identifier nodes in here, right, then I don't have to do this. I can just say well, first of all, I can say dest next is 0. Dest line number is source line number. Dest and then here's what I'll do. While source equals source next, dest next equals 0, the line number equals source line number, if source node, otherwise, if it's just the text, we can just copy it over, right? And then we're going to say if source here, we need to dest next equals push type. This needs an arena. Or it just takes the parser, and we can use the parser's arena. And a metagen identifier node. And then dest equals dest next. Okay. We can just copy the text over. If it's a node, we need to say that dest's node is create node copy of source node. Right? I think that's it. Then we create a node copy. We will also copy identifier list of we'll say metagen identifier node source ident is get node identifier of source, and dest ident result ident get node identifier result. I think we can just do this. We can just say copy identifier list from the source to the result. I think. We can say if source ident and result ident. So if they both have one, which I guess they would have to, huh? which is fine if they both have one. Create node copy. Wait, what? Oh, this has to come. This has to be forward declared because C++. Hooray. 1035. This does not have to be a pointer. It already is one. Source ident. Oh, copy identifier list takes the parser. Oh, global parser. Oh, okay, we don't actually need this. I forgot how the system works. Once we're here, we have a global parser. I forgot about that. Okay, well, we're still not seeing the thing, but we're not crashing, so that's okay. Let's see what we copy. We'll do this in this case, and we'll do this in this case. We will print node nicely, dest node, true. Let's try that. Do I not have that here? Oh god. Damn it. I hate this. I need to reorganize this at some point. And I can't do print AST either. Erg. Okay. Here we go. What are we looking at here? Copy identifier list. When we call this, let's also print a source. And let's just print the source before we do that. Okay, so this is arg to arg. Okay. Arg to arg. We copy the text arg, and then for std arg file number, we copy the text std, and then for the sub concat node arg, we copy the text arg, the node. Okay, that's not right. Something's not right there. Because we set its text equal to 0. Oh, hold on. No, that should be right. You know what? Let's step through this because I am confused and I don't want this here. I don't want it there. Okay. Let's see. Let's step through this. Let's do a little bit of code stepping. Where are we? We want to be in code gen. We want to be in copy no, we're in here. Copy identifier list. We want to be right here. Or no, let's go here. Okay. So the source is a parameter called arg. So whose parent is a snippet. Okay. So we are making a copy of this snippet, this whole thing, to stick right here. That's what we're doing. So we're just right now making a copy of this, which is fine. So our destination is the copy we just made. It is a snippet. Oh, no. Yes. Yes? No, it's a parameter. Duh. That's what we're just looking at. It's this thing. It's this thing's identifier, which all it has okay, now I'm confused. Oh, right. Okay. All it has is text arg. That's it. So this should just be a straightforward copy. Boom. Go to the next thing. So now source next thing. There is nothing else to copy from that identifier list. Okay. Wait a minute. Hold on. Let's go back. Let's actually go here. So we're replacing a snippet call, right? So the source is a snippet. The copy should be another identical snippet, which is fine so far. Okay. The result type should turn into a snippet. The line number should turn to 33. Gets the flags, gets its... Oh. It's info. It gets all of this, including its identifier. Huh. Okay, we won't worry about that for now, but for each child, its first child is the parameter, who we're calling arg. So we create a copy. Gets the parameter, line number, node flags. Here's where info comes in. So this info has an identifier with just text arg. This will also now get an identifier with text arg. And it doesn't have any children. Okay. And now these identifiers are going to be exactly the same. They're the same identifier because we just copied it here. They are the same identifier. Okay. So now we're going to copy it over. So now, these are the same thing. I'm going to copy those over. Source doesn't have a node, it's just text. We copy the text. We don't actually have to do that in this case because it is already the same thing. Source is next is nothing. We're done. Okay. Next child is the compound statement. Okay. And its children are a function call called write. So we're just copying that verbatim, that's fine. And that shouldn't have anything to do there. Wait, what's happening? Okay, I just lost track of everything there. We go through this again. Parameter. Compound statement. We're going to go in there. I'm going to turn this off now. So now we're in the compound statement. Function call. This is the right function call. We do it. Okay, right. We have to go into that thing's children. Okay, that's where I got confused. Compound statement. Okay. Boom. The child is a function call. We're going to go in there. Okay, the result is now another function call. We copy its info, which means this expression, which is a declref with an identifier called write. Okay, that's fine. That's not actually what I'm looking at. I'm looking at the children here. This thing, this declref is what I'm interested in. It has an expression, or it has an identifier, which is text, another declref, and more text. And we copied that over verbatim. Pointers and all, I think. No, we didn't. Oh, because those are the children. Okay, hold on. Okay, hold on. We might not be as bad as I thought. So for this declref, okay. Boom, 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 boom. Now we created a copy of that. Yes, now we created the copy of the identifier. Okay. Okay, now we can look at this. So okay. So dest, I need to just wipe its next off of the face of the earth, which I do. I set its line number, it already has a copy of it. If the source has a node, it doesn't in this case, it's just text. We copy the text over, it already has it. Go to the next one. Great, it's a decal ref. So because there's a next one, I need to give this thing its next back, which I did. Boom. And now I need to keep copying. Boom. 0. Line number. Source does have a node in this case. Does have a node in this case. So we will create a copy of this decal ref. Okay. The result is a decal ref who has arg. Wait, what? This is just arg? Yes, I'm copying. Okay. I'm copying that inner node. Yes, okay. Which should be arg. Okay. Jeez. All right. So this one, I just copied this. Result is the decal ref. Okay. That, I think, is where the problem is. This decal ref has no node flags. That, I think, is the problem. It just didn't have any to begin with. Why? That's what this should be doing. No, we didn't hit it at all. Really? How is that possible? Okay, color me confused. We're just never putting any concat nodes on the tree. But we're parsing the expression, though. We have to be. I am very confused. Let's hop into parse identifier. Next, wait, is null. Oh. I need to recompile. Okay. Next is num arg. So we are parsing this right, or we're lexing this right now. Not this. Okay, well, that's already not what I was expecting. Let's go here. Next is a preproc snippet, okay. Expect an identifier. Next is an identifier. Testing. Okay, we got it. Okay, its name is just name. Next is a parent open. We expect that. Okay. Parse param decals. It's an identifier next, which is args. That's fine. Okay, we don't actually care about this. Next, okay, we're parsing a snippet, and that's our new root. Okay, that's fine. Okay. Next is a curly open. So we create a compound statement. Next is an identifier that starts an expression because the identifier is called write. Okay. Okay, we parse the expression. The next token is the write. So we get that. And then the next is a open paren, which when we see that, it's a function call. So we parse as a function call. Next we see an open paren, parse call parameters. Next, we skip it. Next is the std. We parse an expression. We see it's an identifier. So we parse a name here, is what we're doing. Okay? Next is an identifier called std. It's not a concat node, so we get its text. Oh. I think I see the problem. Next, it's a concat node. Okay. Okay. Here's where we have to add that flag. So what is that other place? What? Parse identifier. Parse name. This assumes the next token is true according to token is name. Each through identifiers returning a linked list of potential identifiers. So what's parse identifier? I'm so confused. Why do I have two of these? What is this? Why do I have two of these that look like they're doing different things, but they both return identifier nodes? Okay, so this looks at the next token. If it's a concat and we're not in a snippet, we error. We skip past the concat. We append an identifier node. The next thing. And while there's more, we keep appending. This, we look at the next thing. If it's a name, if it's a concat node, we do that. Otherwise, we do that. And when do we use this? Parse name. We use it in one spot. Expression leaf. This is like the good, solid case. When do we use parse identifier? We use it on bit fields. We use it on parse enum member. Okay, can we remove this? And then parse identifier, parse name. Okay, well, it looks like we still compile. Okay. That's very confusing, but it's fine for now. So, parse name is where this token needs to go, or this flag needs to go. Target node flags or equals token node flag concat. Are we back now? Are we doing what we want to do? There we go. Now we see it. Holy crap, what a wild goose chase. Node flags concat. This is in util. Node flags concat, which means we're also copying them correctly, right? So before, if I go to copy, create node copy, if I remove this part, oh, well, we still see it because it's, even though it's a shallow copy, all the pointers are still the same, so we're doing a deep copy of it now, so that's fine. It's whatever. So now we can see that it's flagged with a concat node. If I don't put that check in, well, there's no other ones that have nodes, but theoretically, if we're not, right, if I go in here and say, we'll have another one that's just arg. Right? Now we should see both if I don't put this in. We should see both of these. Oh wait, no, because we're huh. Oh, right. The only time this thing will have a node is if it's a concat node. That's the only thing we use it for. In the future, there might be other node types that I throw on identifiers, so that's why I'm doing this. Never mind. So the only time we'll see a node is if it's a concat node, so that's fine. That makes sense. So now, what time is it? Oh my god, okay, it's getting late. God, I really want this to work though. Okay. After all that, we can see all the identifiers that have concats in them, which is what we wanted. So, I think I wanted to say, is concatenated, and we'll say is concatenated is true, and we can break out of this. So boom. Finally, we'll say if not is concatenated. We can just continue. We can skip this one, and then if we just write the output of target name. So once again, boom. Great. Okay, so now we have the name. Let's undo this comment here. And actually, let's put this in a if 0, so it's, oh god, for coder is, okay. Can I just put a, yeah. Okay. We don't care about this, or this. The new name will be an identifier, actually, that we're constructing. We're constructing we're constructing an identifier for the new name. Let me see here real quick. Yeah, we're constructing identifier for the new name. It won't be a string, so for now, I will remove this. We do not need this at all. Try to match the name to one of our parameters. Right, so I want to see if any of these concats, whatever I'm concatenating, is coming from an argument. Which, does that make sense that we're only doing parameters? Should we be able to concatenate other things? I'll put it to do in here. Okay, so param match index for each param if our constructed node name is equal to our target name, no, is equal to this logic should go in here. Forget all this. This should go in here. We don't have to break. As long as we have an identifier piece chunk that we're looking at. So I'll say identifier piece. Right? So every time we're going through, we're looking at each piece of the identifier. So in this case, it's std to start. Does that match? Well, first of all, is that a concat? No, it's not. So actually in here, let's turn this off for just a sec. We are going to write output construct node name of identifier piece node. That's what I want to see. So this should show us just arg in there. Identifier piece. There. Okay, great. So we're seeing for every part of this identifier, std, does that need to be concatenated? No. Or does that need to be matched to an arg? No. This is a concat node. Oh, this does have to be matched because we don't know what this could be. This doesn't. So now let's grab this and say piece text is this. Now, for each parameter, if the parameter name equals the piece text, we are going to say, let's just write out piece text. So now this should again just print out arg because we found a match, right? If we somehow had another concat here that had like not a match, this should not print that here, right? Which it doesn't because it's not a match. If this one also matches it, we see it twice. Okay, great. So we're matching a identifier piece to one of our parameters. So now we want to, what are we doing next? We're saying this. So once we've matched, boom, write output int to string param match index. So now we just want to verify that we're matching on the right parameter. 0, right? First parameter. So if this took 2 parameters, right? arg2 test Say we want to match to arg2 here. This should be a 1, which it is. 0, great. Still going strong. Okay. Grab the next piece. If we didn't find a match, let's do this. Okay, so we didn't match. We tried to match the identifier piece text to a snippet parameter, and we are at identifier piece, right? No, we are at identifier piece node, I think. Let's try to trigger this error. So if we can't match it, unable to match concatenate identifier args to snippet parameter. It doesn't know the location, right? This has to instead be the target. Line 34 in main DB. Yes. Okay, great. Awesome. Although, wait. That identifier piece should have a correct line number. So why doesn't it? Parser name context. Parser. So this is this one. We're passing in a line number. But we're not, though. We're passing in the parser, a token, and a context. Parser, token, context. It's this one. So we're getting the line number from the name. So where is that coming from? Next. Why is next's line number not correct? It's a token concat. Do those not get a line number? I'm confused. No, it does. It totally gets a line number. Let's move this up here. And just use them. Okay, why doesn't it have a line number? I'm confused. Let's go in here. This is online parse name. Right here. Nope, don't care about you. Okay. Identifier. Line 34. Create a declref node. Boom. So declref node is target. Oh, that's the piece. So the piece has a line number. The identifier does not. Identifier piece should have a line number. Oh, it doesn't have a file though. Where is it getting the file from? Parser, current lexer, file path. No, this is report error and exit. Report error. Get node source file. Oh! Because this node is not on the tree, so I can't get, it doesn't have a source file. It's not on the tree. That makes sense. That's why. This node is not on the tree. So what this needs to have is crap. I can do something really lazy here. I can say this target node parent is equal to get source file, target. Let's just set their each one to the target node. Which that's not so bad, I guess. That's not the worst thing because it makes sense, even though I'm just really doing it to get error messages here. Target node parent equals no, this is a wait, we're parsing a name. So I don't have the I'm creating a declref node as part of why is this so confusing? This thing, its parent, right? This whole identifier, boom, 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 this whole linked list is part of a declref. Yes? Yeah. Parse name. Target. Yeah, it's part of a... Okay. When we append an identifier node, we're going to return that node. And we're going to say this if ident parent ident node parent equals result, and then if it has a next one, and next node parent equals target, or equals target node parent. So down the chain, they will get each other's parents. Something like that. So this will be node. Wait, so we push one onto the end. We append it to a list. If the list has things on it, then we create a new one on the end. Oh, this is list node parent. Okay, is that here that broke it? No, what did I do? Okay, I want each node of the identifier to just have its parent set to the overarching node. That's all I want. Which should be parse name. Okay, how about parse name takes parent. Then this can be equal to 0 if target node parent equals parent. Okay. And that, oh, because we aren't guaranteed to be a node. Right. That's only mattering. Duh. I think this was working before. I just wasn't thinking this through. This only matters in the case where we made a node. Duh. Okay. Jesus. Okay. In this case, okay, that doesn't actually work there. Architecturally, this is making this a lot harder than it needs to be, which is unfortunate, but this needs to use decal identifier, not decal name. I don't think that matters anymore. We are now going to I'm really confused about these two functions. Okay. You know what? This is gonna be slightly wrong, but I kind of don't care at this point. Too many other things have to change to make that work properly. Basically, this identifier node here is getting its line number from the whole thing, which is technically not correct because I can think of scenarios where those two things might differ, but it's fine. It means the line number might be off in very rare circumstances. I didn't need to rabbit hole on that. I didn't even get anywhere, so that's fine. So if you get it wrong, tells you, hey, I don't know what you're telling me here. Here you match it, okay. If we found a match, okay, does that work? We segfault now. Okay. Which part of this? Okay. Is it resolves to literal? Yes. So let's print AST of matching call site node just to see what we get. Node nicely. Oh, okay. So you know what? These is a call, so we don't start it. Okay. We remove having to do the +1. There we go. Okay, that's why. Can only concat things we can resolve at compile time. So why can't we do that? Let's step through this now. Let's see where we're at. At compile time. Boom. Okay, so our param match is 0 because we're matching arg. Matching call site node is the decal ref, whose name is out, right? So we matched arg here to out here. We matched those two up. Resolves to literal is literal type. It is not. It is a decal ref. Okay, that makes sense. So I actually don't think we want to do this right yet. Okay, so what do we want to do in this case? New name. We want to replace this with this. So we want to say identifier piece node equals 0. Identifier piece text equals construct node name of resolved matching call site node. Or no, matching call site node. Okay, there's no way we just worked. Because now there's no error here. There's no way that worked. There's no way that that worked. I kind of don't want to believe that. Okay, that line number is still screwed up. But would you look at that? We are concatenating, folks. As you can see, I wrote testing and I passed it capital out. And what did it do with it? Write std, whatever I passed it, underscore file number. So std out underscore file number. Yeah, that is doing what we want. So why is it not building is my question, or why is it not running is my question. Oh, because we're treating warnings as errors. So that ain't gonna print. We work. And if I say this is like error, we work. Because we're printing the standard error now. Which means if I pipe this, how do you do this too? There we go. This is working. Now if I say this is fail, This is going to be like, hey man, I don't know what std fail is. That ain't a thing. Dude. There's a lot more work to do because now I have to support all the other types, not just function calls. I have to support all the other types and make sure that this works recursively in snippets and side snippets, stuff like that. But proof of concept, this works. First step, this works. That's crazy. That doesn't work. Passing normal things through doesn't work. So we'll say that doesn't work. We'll figure that out. But hey man, we have concatenation working. I should be able to say even weird stuff like RIT and concat arg. Oh no, because okay. Right. We're only doing this in one spot right now, and that's parameters of function calls. Like I said, I gotta make it support the other types now. So this I don't think, yeah. So this just replaced it with a W. It doesn't know about any of this other stuff. Right? It doesn't know about, although that's weird. I feel like that actually should work. And I wonder if that has to do with me replacing all those parse names with parse identifiers. Or other way around. To do this doesn't work. Does this have to do with me replacing all of those parse identifiers with parse names? I did it without really thinking. Okay. Let's do this doesn't work. No, this does work. This is fine. This doesn't work. Regular argument passing is busted. Okay. I'm okay with this. Testing 2, and we'll do a testing 0 just because. This should be, wait, how did that work? Hold on. Oh, right. Yep. Okay, so 0 shouldn't work, which we know. 2 shouldn't work, which we know. That works just great, though. Awesome. Okay. That is such a big milestone. What has to happen next is I do want to figure out these 2 weird cases, because I want this to be, like, totally solid before moving on to the other types. So, like... Well, I think this is because we don't support the other types. Maybe... This is just busted. I have to just figure this, or fix this. This I'm not sure about, but then, hey man, we have concatenation in snippets. I'm gonna call that a win. All right. Well, thanks for watching. Very excited that this is working as well as it is. Let's see how much code that was, because I'm curious. Wait, how do I... Is it this? There we go. Yeah, it wasn't really that much code, you know? It really wasn't. It was mostly updating do concatenation and then our replacement logic. The other stuff were all just little simple bug fixes mostly. So, all right, cool. Thanks for watching if you decide to hang out, and I will definitely catch you next time. I'm getting closer to being able to use this thing. I'll talk to y'all later.